Welcome back to Triomeet. In this lecture today, we'll be solving numerical questions from the exercise part of units and measurements. So let's start solving. First part 2.1. A part, the question is the volume of a cube of side 1 centimeter is equal to dash meter cube. So what is given to us? What is given to us is cube of side 1 centimeter. What you defined? Volume in meter cube. So to convert this, in order to solve this, we have to convert this to meter cube. Why? A question is converted to meter cube. We define volume in meter cube. So let's convert this to meter cube. So we know 1 meter is equal to 100 centimeter. So how much is 1 centimeter equal to? That will be equal to 10 power minus 2 meter. Substitute this value here. So we get A in terms of meter as 10 power minus 2 meter. Now, in order to calculate the volume of the cube, what is the volume formula? Volume is equal to A cube. Right? Now, so the final answer will be 10 power minus 2. The whole cube will give you 10 power minus 6 millimeter cube. But here in the question we have take care of significant figures. Now, we know in the case of multiplication or division, the final result should contain as many significant figures as in the original number with the least number of significant figures. So the original number here is 1 centimeter. How many significant figures is this? 1. Now, what about when we converted it into meter? This is also 1. So we know that when we convert from one unit to another, the number of significant figures should remain the same. So the final answer should also contain only one significant figure. Let's check here. What is the number of significant figures here? It is 1. So our final answer is correct. So this is our significant figure. Now let's go to solving B part of the question. So the B part of the question is, we have given, what is given to us? The surface area of a solid cylinder of radius equal to 2.0 centimeter and height equal to 10.0 centimeter is equal to dash millimeter square. You define surface area in millimeter square. Now, how many significant figures are there in this? It is 2. Because even if it was just 20, the answer would have been just 1. The trailing zeros are insignificant. But here, since we have the decimal point, the 0 is valid. So it becomes 2 significant digits. Height also. The number of significant figure here is 3 because of the decimal point here. The zeros will be valid under significant figures. So our final answer should contain 2 significant figures because the final answer should contain as many significant figures as it is in the original number with the least number of significant figures. Here the original numbers are 2 and 10. So here the least number of significant figure here is 2. Now let's calculate the surface area of a cylinder. The surface area of a cylinder is given by 2 pi r square into 2 pi r square plus 2 pi RH. Surface area is 2 pi r square plus 2 pi RH. Take the common terms out, we get 2 pi r into r plus h. So in order to get a final answer of millimeter square, you have to convert from centimeter to millimeter. So in order to convert it from centimeter to millimeter, you have to multiply the values by 10. Multiply it by 10. So we get radius is equal to 20 millimeter. Height is equal to 100 millimeter. But even if we convert, we should get as many significant figures as before, right? So here just put a decimal point there. So then our significant figures will be correct. So here it is two significant figures. Here it is 3 significant figures. Substitute the values here. We get 2 pi into r. R is 20 mm. 20 mm plus height is 100 mm. We get the value to be 480 pi millimeter square. That is 15072 millimeter square. But our final value should contain only two significant figures. Therefore, we can write this as 1.5 into 10 power 4 millimeter square. Even if you open this, we get the same value, that is 15072. So this is our final answer. 1.5 into 10 power 4 millimeter square. Now let's solve the third part of the question. A vehicle moving with a speed of 18 km per hour. So the speed is given as 18 km per hour. It covers how much meter in 1 second? So you have to convert this into meter per second. That is our question. Now, how much is 1 kilometer equal to? It is equal to 1000 meters. How much is 1 hour in terms of minutes equal to? 60 minutes. How much is 1 minute is equal to in seconds? That will give you 60 seconds. So then 1 hour is equal to 60 into 60 seconds. So we get 3600 seconds. Now substitute these values here. So speed will be equal to 18 into, to convert from kilometer to meter, multiply by 1000. To convert from hour to second, multiply by 60 into 60 or 3600 seconds. Now let's simplify this. So we can simplify this by 2. 2 5 is 10, 2 3 is 16. So we get 18 into 5 by 18 meter per second. So we get a final answer to be 5 meter per second. This is in terms of meter per second. But the question is, how much meter does it cover in 1 second? So that will be distance is equal to speed into time. Speed is 5 meter per second. How much is times? 1 second. When you multiply this, we get 5 meters. In significant figures, how many significant figures does this have? 2. So final answer will be 5.0 meter. In order to contain 2 significant figures. Now, an easy hint it is to convert from kilometer per hour to meter per hour. Just multiply your value by 5 by 18 in order to convert it to meter per second. Now, let's solve the fourth part of the question. So what is given to us is the relative density. The relative density of lead is 11.3. Its density in gram per centimeter cube or kilogram per centimeter cube. So let's first solve the gram per centimeter cube. So the question here is relative density is given. You have to find the density of lead. Now what is the relative density formula? Relative density is equal to density divided by density of water. So what is density of water in gram per centimeter cube? In gram per centimeter cube, the density of water is equal to 1 gram per centimeter cube. So let's substitute these values here. So in order to find the density of lead, multiply relative density by density of water. We get 11.3 into density of water is 1 gram per centimeter cube, we get 11.3 gram per centimeter cube to be the density of lead in gram per centimeter cube. Since here the relative density, the significant figures is 3, our final answer should contain also just 3 significant figures. Now, in terms of kilogram per meter cube, right? How to solve this part? So we know in gram per centimeter cube, it is rated as the density of water is 1. What about in terms of kilogram per meter cube? So in order to convert from gram to kilogram, multiply by 1000. To convert centimeter cube to meter cube, multiply it by 10 power minus 2. So you get here it to be 10 power 3 by 10 power minus 6 to be equal to 10 power 3 kilogram per meter cube. Substitute these values here. So we get density is equal to relative density into density of water in kilogram per meter cube. So we get relative density to be 11.3 into density of water is 10 power 3 kilogram per meter cube. So this is a final answer in terms of kilogram per meter cube. So we solved the first exercise question.